Today we are going to study two-port network. What is two-port network? Suppose this is an AND network. If the current entry, first of all we need to know about the port. Any two terminal where the current enters and leave. These are the two terminals, T1 and T2. Then this T2 will be called as port. But terminal T1, T2, if suppose T3 and T4, T3 and T1 will be not called as port, because here it is not a port, because here current that is entering is not equal to the current which is coming out. So we need, if there are two terminals, there must be a condition where that the current entry must be equal to the current coming out. So for the port to be, so port is defined in this manner. Now suppose if I am taking a network, then these two, because the current I will be coming from here and I will be coming out from here, so these two port will be termed as port. And if there are two port in any one network, suppose this is second port, yet a current entry will be coming same, so this is port 2, so this is port 1. So this type of network is called two-port network. Now if you see, if I see the network, suppose this is a network N and this is your two port. Now we can define it by voltage and the current that will enter I1, and this will be also entering current and voltage across 3. So 4 quantity that we are dealing with, V1 I1 and V2 and 4 electrical quantity. 4 electrical quantity we are dealing with. Now we will be combining any two electrical, two will be dependent and two will be independent source. We will be giving either V1 and V2 and measuring I1 and I2. So same way, there will be two dependent and two independent quantity. We have 4 variable. What are 4 variable? V1, I1, V2, I2. And out of these 4 variable, we need to choose 2 dependent and 2 independent. So there will be coming in 4C2. It will be giving 6. So total there will be 6 combination. Now out of 6 combination, we need to specify each one of them. Now I am specifying each one of them. Now writing dependent and independent. Dependent, second one independent, and what are the types means description. Now suppose in this network, now I am taking network here in a small, this is your V1, this is your V2, this is your I1 and this is your I2. Then if V1 and V2 they are dependent on the current I1, means suppose we are giving I1 and I2, then this description are called Z parameter or open circuit parameter. Now if I reverse this combination, if I take I1, I2 and if I give V1 and V2 and if I find I1 and I2, this is called Y parameter or short circuit parameter. Now if you see, these two are reciprocal to each other. We will be showing this in next classes. Now if I take V1 and I2, if I take V1 and I2 as dependent, V1 and I2 as a dependent, then what will be our independent will be I1 and V2. We term this as a H parameter. This parameter is highly used in electronic circuit, means transistor circuit. And if I reverse this one, if dependent is I1 V2 and independent is V1 and I2, this is called G. These two are inverse in nature. Now if the dependent V2 I2, as we have in our system, we get voltage and current from the subsystem, that is V1 and I1 from the substation. So this is called, from the substation V1 and I1 is fed and we receive V2 and I2, that is called transmission parameter or ABCD parameter. This is used in power system or communication system. And if I reverse V1 I1 and V2 I2, this will be termed as inverse transmission parameter. So here there are 6 classification of this one. First one is called G parameter, second one is called Y, third is called H parameter, fourth is called G parameter. This is your transmission parameter, this is your inverse transmission, this is Z, Y, H and G parameter. So this is how we term each of them. Now let us study the Z parameter. Now writing Z parameter, now taking the network N, and this is your plus V1 and V2. Now what we have seen that in Z parameter, first one Z parameter dependent was, what was dependent? V1 and V2, and independent was I1 and I2. So we need to give the current I1 and I2. Now we apply the current source I1 over here, and here I am applying the I2. These are the current source that we have applied, and we will be measuring V1 and V2. Now if we need to measure, we need to find V1, then V1 will be a superposition of I1 as well as I2. So we can write V1 is I1 plus I2, means superposition. Once it will be open, we will measure the effect of I1, and in second time this will be open and we will measure the effect of I2. And what here it will, because this is a voltage, then there must be some resistance or impedance, then only it will give us voltage. So constant will be Z11, here the constant will be Z12, this is Z12. Now if you want to measure V2, this is also, there was two dependent V1 and V2, here also it will be sum of I1 and I2. Now here what we will do, then again there will be a superposition. Now we are terming this as a Z21 and this as a Z22. From this we got V1 to V1 V2 is nothing but Z11, Z12, Z21 and Z22. This is I1 and I2. This is your independent parameter and this is your parameter. In order to solve any question regarding this parameter, we need to give I1 and I2, and we will be measuring V1 and V2. Now why this is are called open circuit parameter, we will see this. This is called open circuit parameter because if you want to measure Z11, we need to open. If you want to measure any of the Z11, Z12, Z21 or Z22, we need to open circuit the network. Suppose we need to measure the Z11. Now I am writing V1 is equal to Z11 I1 plus Z12 I2. Now if I am to measure the Z11, what we need to do? I2 equal to 0, or we need to open circuit I2. When I will be I2 making 0, then Z11 will be V1 by I1. Now if I want to measure Z, suppose I am writing second equation, that V2. If I want to measure Z22, Z21 I1, Z22 I2. If I need to measure Z22, then I will making I1 0, then Z22 will be V2 by I2, keeping here I2 0 and here I1 C 0. See, for making any of Z11 and Z2, we are seeing that one terminal is open, that is why it is called open circuit parameter. Moreover, you see this is measuring the voltage and current at same terminal, at same port, so this is called driving point impedance. Driving point impedance, because it is Z11 will be called as driving point impedance because it is measuring the voltage and current at same port. This is the ratio of voltage and current at same port. Simply this will be Z22 will also driving point impedance at port 2. Now we are left with the Z12 and Z21. Now if I find Z12, now let me take another sheet. For Z12, now let me write the equation. Z12 V1 is equal to Z11 I1 plus Z12 I2. Now I need to find here Z12, then what I am going to do? I1 is equal to 0, then V1 by I2 is going to give me Z12 having I1 equal to 0. So this is measuring the voltage of one terminal and current of another terminal. So this is called transfer impedance. And here also what we have seen, that here also one port I1 is open. Now if I find this one Z21, if I find Z21, then what we are going to get? V2 is equal to Z21 I1 Z22 I2. If I want to measure this one, I will be keeping I2 is equal to 0, then V2 by I1 is will be Z21 keeping I2 equal to 0. So here also it is measuring Z2 voltage of second terminal and current of first terminal. So it is also called transfer impedance. Now if Z12 equal to Z21, then it is called reciprocal. If they are equal, then it is called reciprocal. These are equal, then it is called the reciprocal function. Now if these two are equal, then there will be a 4 terminal, there will be a 3 terminal show of 4 port network, because in 4 port network, a 2 port network, we need 4 terminal, but for 2 port network, when we see only 3 terminal, it means it will be assumed that the network is reciprocal. Reciprocal means here Z12 equal to Z21, means a network can be a 2 port with a 3 terminal, and a network must be a 2 port with a 4 terminal. But if it is of 3 terminal, it means that it is reciprocal, having Z12 is equal to Z21. Now I am making in 3 terminal having Z12. Let me write the equation once again. V1 is equal to I1 Z11 plus I2 Z12. V2 is equal to I1 Z12 and I2 Z22. This is the equation that we are having. Now I want to make it in a 3, because this is a 4 terminal. Now I am making it in 3 terminal mode. Now for that, what I am doing? I am adding and subtracting I1 Z12, I1 Z11 minus I1 Z12, and same things I am adding I1 Z12 plus I2 Z12. So this will become, I1 will be common, so I1 will be Z11 minus Z12, and here if I take I1 plus I2, because Z12 and Z12 are same, so this is the equation that we got. V1 is equal to I1 Z11 minus Z12 and I1 plus I2 is equal to Z1 into Z1. Now taking V2 I1 Z12, now adding I2 Z12 and subtracting I2 Z12 I2 Z22, then what we are going to get? Now here Z12 will become I1 plus I2, and here I2 will be common, Z22 minus Z12. So we are having V2, V1. If you look at this equation, V1 and V2. Now if you draw the corresponding resistance, then this is your nothing but Z11 minus Z12, and this terminal is nothing but your Z12, and this terminal is nothing but Z22 minus Z12. Now this is your I1 entry, this is your I2 entry, this is your plus minus V1, and this is your plus minus V2. Now if I see this terminal, now this has reduced to three terminal only, because one terminal is common to both port. So we have reduced into three terminal. Now if you see Z11, it is a combination of this one and plus impedance looking from this one. If I add these two, then it is going to Z12 and Z12 get cancel, and we are left with Z12. Now if I add these two, it is going to give me Z22. If you add this one and this one, you are going to get Z2. Now suppose I am making one example. This is the parameter that we have taken. Now suppose this is the parameter we have taken. Now I am taking this Z1, Z2, and this is your Z3. Now we need to calculate the Z11, Z12. This is V1, this is your I1, this is your V2, this is your I2. Now we need to calculate the parameter Z11. For calculating the parameter Z11, what we need to do? Going in equation way, by equation way, if I write Z1 parameter, then V1 is nothing but we have equation I1 Z11 plus I2 Z12. Now we need to find Z11. Then for that I2 will be 0, means there will be open circuited at I2, and Z11 will be V1 by I1, means V1 by I1 means your Z1, means when this is your open circuit, then this branch will not come in effect. And if you see the impedance looking at this terminal, what it is going, the sum of these two, Z1 plus Z3. So Z11 will be Z1 plus Z3. Z11 will be Z1 plus Z3. Now if you want to find Z22, Z22 will be V2 by I2 by keeping I1 equal to 0. Now V2 by I2, we need to look at this terminal, and what will be the impedance, as I1 is 0, keeping I1 0, this is will be combination of Z2 plus Z3. Now if we want to find the Z1 2 or Z21, because this is a reciprocal where Z12 will be equal to Z21. Now I am, what will be the V1 by I2? This is the value that we need to find, as I1 V1 by I2, keeping this will be the equation of Z21, keeping I1 equal to 0. Now if this is I1 is equal to 0, then what will be V1 by I2? What will be V1? If I want to calculate V1 will be nothing but I2 into Z3. V1 will be I2 into Z3 or Z3, then Z3 is equal to V1 by I2. Now if I compare, V1 is equal to V1 by I2 is nothing but your Z21. So Z3 is our Z21 or Z12. So we have seen that following Z11 is Z1 plus Z3, Z22 is Z2 plus Z3, and Z12 or Z21 is equal to Z3. Now if I compare with this what we have derived, now suppose this is the we have derived, and then if I compare this with the problem that I have taken, Z1, this is your Z3 and this is your Z2, Z3. Then we have calculated this result that Z1 will be Z1 plus Z3. Now if I add these two, if I add these two, then what we are going to get, Z1 2 will cancel, Z1 minus Z1 2, so we will be having Z1 1. From here also by comparison also we can see, and this will be equal to Z3, Z1 2 is equal to Z3, and if you add these two, then it will be equal to Z22. So this is the what we call, but comparing or by shortcut also it is just write in T form. This is T form of Z parameter. So this is all about the Z parameter, the theory related to Z parameter, and it is easy to solve the Z parameter in this